The universe is vast beyond human intuition. Vastness like this is impossible to imagine. Numbers stop meaning anything. Billions of stars in a galaxy, hundreds of billions of galaxies in the observable universe, 13.8 billion years of cosmic history. With this scale, the odds seem clear. Life should not be rare, intelligence should not be rare, civilizations should exist everywhere, signals should cross light years, structures should blot out stars, space should be loud. Yet it is silent. For over 60 years, humanity has searched the sky. We have pointed our instruments at distant stars. We have scanned radio waves, optical signals, repeating sequences, anything that could not occur naturally. We have listened for patterns in cosmic noise. And we have heard nothing. No greetings, no signs of life, no messages from young civilizations discovering fire or ancient empires harnessing the energy of suns, nothing but silence. This silence is not neutral, it is not comforting, it is unsettling in a way that seeps into the mind, because silence at this scale should not exist. Probability predicts abundance, yet the universe looks empty from our vantage point. And this is the heart of the Fermi Paradox. Enrico Fermi asked a simple question over lunch decades ago. He wondered aloud, why, given the age and size of the universe, have we not yet seen evidence of other intelligent life? Where is everybody? It is a question that seems almost casual, spoken between bites of food, yet it carries a weight no one anticipated. The silence of billions of stars is not merely empty space. It is a challenge, a question that humanity is still struggling to answer. Every new observation only deepens the paradox. Every discovery of exoplanets, of potentially habitable worlds, of distant stars older than the sun, only magnifies the emptiness. And this is what makes the question terrifying. It is not just that we have not found others, it is that the universe, by all indications, should be filled with them. Every calculation, every model, every theory predicts life should be everywhere. And yet, here we are. Alone it seems, or at least unseen. This sets the stage for a disturbing thought. Perhaps intelligence is fragile. Perhaps civilizations destroy themselves before they can reach the stars. Perhaps something else is keeping the universe quiet. Something so powerful that entire civilizations remain hidden, silent, or extinct. And that is where we begin to explore the Fermi Paradox in full. The possibilities range from the hopeful to the terrifying, from the cosmic to the intimately human. The question that broke science. In the summer of 1950, a group of physicists were walking to lunch at Los Alamos National Laboratory. These were not ordinary scientists. They were the architects of modern physics, the minds behind nuclear theory, quantum mechanics, and the atomic bomb, people who understood the universe at a level few humans ever have. As they walked, the conversation drifted towards science fiction and UFOs. Newspapers at the time were filled with jokes and speculation about flying saucers. Someone made a casual remark about aliens visiting Earth. Then Enrico Fermi stopped walking. Fermi was not dramatic. He was calm, precise, and famously direct. He had an extraordinary ability to cut through complexity with a single sentence. After a brief pause, he asked a question. Where is everybody? That was it. No equations. No charts, no elaborate theories, just one simple question. And yet, that question quietly detonated one of the most profound problems in science. Because Fermi was not joking. If intelligent life is even moderately common in the universe, then some civilizations should be millions or even billions of years older than humanity. With that much time, even slow technological progress becomes unstoppable. A civilization does not need faster than light travel. It does not need impossible technology. Even with tools only slightly more advanced than ours, a species could colonize its entire galaxy in a few million years. On cosmic timescales, that is almost nothing. They could send probes to every star system. They could build massive structures. They could leave behind signatures that would be obvious across vast distances. And yet the sky remains empty. No alien ships in our solar system. No massive energy collectors surrounding distant stars. No ancient ruins drifting silently through space. Nothing. This contradiction became known as the Fermi Paradox. On one side, we have overwhelming numbers, trillions of planets, billions of years, chemistry that naturally produces life. On the other side, we have complete silence. The paradox does not simply ask why we have not seen aliens. It forces a much darker conclusion. Something appears to prevent civilizations from reaching a stage where they become visible. Whatever that something is, it must be incredibly effective. It must eliminate or silence almost every intelligent species before they spread across the stars. Because if even one civilization had succeeded, we would almost certainly know by now. This realization reframes the question entirely. It is no longer just, where are the aliens? It becomes something far more personal. What happens to civilizations like ours? The numbers that do not make sense. To understand why the silence of the universe is so disturbing, we need to look at the numbers. Not science fiction numbers, not exaggerated guesses, real numbers gathered through decades of observation, measurement, and discovery. For most of human history, we did not even know whether planets existed outside our solar system. Until the 1990s, exoplanets were theoretical. Today, that uncertainty is gone. We have discovered thousands of planets orbiting distant stars, and based on what we can observe, astronomers estimate that planets are not rare at all. They are the rule. In the Milky Way alone, there are likely more planets than stars. Many of these planets orbit in what scientists call the habitable zone. This is the region around a star where temperatures allow liquid water to exist on a planet's surface. Water, as far as we know, is essential for life. When astronomers first began finding exoplanets, many expected Earth-like worlds to be uncommon. That assumption turned out to be wrong. Rocky planets are everywhere, sun-like stars are common, stable orbits are normal. From a purely statistical standpoint, the ingredients for life appear to be scattered generously across the galaxy. This led scientists to formalize the question using a framework called the Drake equation. The Drake equation is not a single answer. It is a way of thinking. It breaks the problem of alien civilizations into steps. How many stars exist? How many have planets? How many planets could support life? How often life begins? How often intelligence evolves? How long civilizations survive? When reasonable estimates are plugged into this equation, the result is not zero. It is often thousands, sometimes millions. Even if life is rare, even if intelligence is rare, even if technological civilizations are fragile, the sheer size and age of the universe should still produce multiple advanced civilizations at any given time. And yet we see none. No radio signals that cannot be explained by natural sources. No laser bursts aimed across interstellar space. No colossal engineering projects visible from afar. This absence is not subtle. Advanced civilizations, even if they were not trying to be noticed, would likely leave behind detectable traces. Energy use on a massive scale, altered stars, artificial light, waste heat. The universe should be full of clues. Instead, it looks untouched. This creates a deep tension between mathematics and observation. The math says the universe should be crowded. Observation says it is empty. When science encounters a contradiction like this, it means one of two things. Either our assumptions are wrong, or something fundamental about reality is missing from our understanding. The more we learn about the universe, the worse this tension becomes. Every new exoplanet discovery strengthens the paradox. Every confirmation that Earth-like worlds are common makes the silence louder. At some point, the numbers stop being comforting. They start becoming suspicious. Because if intelligent life arises easily, and if the universe has had billions of years to produce it, then the absence of visible civilizations demands an explanation. And that explanation is not gentle. It leads us directly to one of the most unsettling ideas ever proposed: the lonely universe. One possible explanation for the silence is also the simplest. We are alone. Not alone in a poetic sense, not alone emotionally, alone in a literal cosmic sense. life itself might be extraordinarily rare, so rare that it has only happened once. Under this view, Earth is not just special, it is a miracle. A statistical anomaly so extreme that it may never be repeated anywhere else in the observable universe. Perhaps the origin of life requires such an unlikely chain of events that it almost never occurs. The right chemistry, the right environment, the right timing, the right planetary history. Miss any one of these steps, and a planet remains forever lifeless. Even if simple life emerges, it may rarely evolve beyond microbes. Multicellular life might be another enormous hurdle. Intelligence might be yet another. Technological intelligence might be the final, nearly impossible leap. In this scenario, humanity sits alone at the top of a long chain of improbabilities. This idea can be comforting. If we are alone, then there are no hostile civilizations lurking in the darkness, no cosmic predators, no ancient empires watching us silently from afar. The universe becomes quiet but safe. And for many people, that quiet feels reassuring. But there is a problem with this explanation. It assumes that every difficult step in the evolution of life happened to succeed here and almost nowhere else. It assumes that the universe, despite its vast size and age, produced intelligence exactly once. That is a very strong claim, and it becomes harder to defend with every discovery. We now know that organic molecules form naturally in space. Amino acids exist on asteroids, water is common, Earth is not chemically unique. We also know that life appeared on our planet relatively quickly. Almost as soon as conditions allowed it, life emerged. That suggests life might not be as fragile as once believed. If life were incredibly difficult to start, we might expect it to take billions of years to appear. Instead, it showed up early. This weakens the idea that life itself is the bottleneck. And even if life were rare, the universe is enormous. Given hundreds of billions of galaxies and trillions of planets, even unlikely events should happen many times. Which brings us back to the same uncomfortable question. If we are not alone, why does the universe look empty? The lonely universe explanation feels simple, but simplicity does not make it correct. In fact, it may be appealing for the wrong reason. It allows us to avoid darker possibilities. Because if we are not alone and if life is common, then something else must be happening. Something that removes civilizations before they spread. Something that filters them out. And that idea leads us directly into the most terrifying possibility of all. The Great Filter. At the center of the Fermi Paradox lies a concept so unsettling that many scientists hesitate to talk about it openly. It is called the Great Filter. The Great Filter is not a single event. It is a category, a step or series of steps in the evolution of life that is so difficult, so destructive, or so unlikely that almost no species ever passes it. Under this idea, the universe may be filled with planets capable of supporting life. Some may even host simple organisms, but somewhere along the path from chemistry to civilization, nearly everything fails. The filter could occur at many points. It could be the origin of life itself. The transition from non-living chemistry to self-replicating organisms may be incredibly rare. Perhaps Earth was lucky beyond measure. It could be the jump from single-celled life to complex, multicellular organisms. On Earth, life existed for billions of years as simple cells before anything more complex appeared. It could be the evolution of intelligence. Dinosaurs dominated Earth for over 100 million years without developing advanced technology. Intelligence may not be an inevitable outcome of evolution. Or the filter could occur later. It could emerge when a civilization develops technology powerful enough to reshape its planet. Nuclear weapons, artificial intelligence, genetic engineering, climate-altering industry. At this stage, a species gains the ability to destroy itself. The most disturbing aspect of the Great Filter is not that it exists, it is where it might be located. If the Great Filter lies behind us, then humanity is extraordinarily rare. We have already passed the most dangerous steps. The silence of the universe becomes a sign of our uniqueness. But if the great filter lies ahead of us, then the silence becomes a warning. It means that civilizations like ours reach a certain level of development, and then they disappear. The universe is quiet not because life never arose, but because intelligent life does not last. This shifts the entire meaning of the Fermi Paradox. The question is no longer why we have not found aliens. The question becomes whether anyone ever survives long enough to be found. Every technological breakthrough then takes on a darker significance. Each new invention is no longer just progress, it becomes a test. Can a civilization manage the power it creates? Can it avoid turning its tools against itself? Can it coordinate on a global scale? On Earth, these questions are no longer theoretical. We already possess weapons capable of ending civilization. We are altering our planet's climate faster than any natural process in human history. We are developing artificial intelligence systems whose long-term behavior we do not fully understand. From the perspective of the Great Filter, these are not isolated challenges. They are potential extinction events. This is why the Great Filter is so disturbing. It does not feel abstract, it feels personal. It suggests that the universe may be filled with the remains of civilizations that reached our level, faced similar choices, and failed. They did not disappear because of bad luck. They disappeared because they crossed a threshold they could not survive. If this is true, then the silence of the universe is not peaceful. It is a graveyard. And the most unsettling possibility of all is that we may be approaching the same threshold right now. The Great Filter does not announce itself, it does not come with a warning label. It simply waits for a civilization to make a mistake it cannot undo. They destroy themselves. If the Great Filter lies ahead of us, then one explanation stands out as both simple and terrifying. Civilizations destroy themselves. Not because they are evil, not because they intend to, but because intelligence grows faster than wisdom and power grows faster than restraint. On Earth, technological progress has followed an accelerating curve. For most of human history, change was slow. Generations lived and died without seeing meaningful differences in how the world worked. Then everything changed. In just a few centuries, we learned to harness fossil fuels, split the atom, alter the chemistry of our atmosphere, and encode intelligence into machines. Our species went from horse-drawn carts to nuclear weapons in the span of a few human lifetimes. This pattern may not be unique to Earth. Any civilization that develops science and technology will likely follow a similar trajectory. Early discoveries unlock new tools accelerate discovery, acceleration becomes exponential. At some point, a civilization gains the ability to eliminate itself. Nuclear weapons are the clearest example. A single technological breakthrough suddenly places extinction within reach, and once such weapons exist, they cannot be uninvented. But nuclear war is not the only path. Climate collapse presents a slower, quieter threat. Industrial activity alters planetary systems. Temperatures rise, ecosystems fail, food systems destabilize, conflict becomes more likely as resources grow scarce. Biotechnology introduces another risk. As tools for genetic manipulation become cheaper and more accessible, the possibility of engineered pandemics increases. A single error or a single malicious act could have global consequences. Artificial intelligence adds yet another layer of uncertainty. Systems that optimize goals without fully understanding human values could behave in ways that are difficult to control. Even well-intentioned designs can produce unintended outcomes. Each of these risks alone is serious. Together, they form a dangerous convergence. The most troubling aspect is that none of these threats require malice. They emerge naturally from progress itself. A civilization does not need to choose destruction. It only needs to fail to coordinate, fail to regulate, or fail to react in time. From this perspective, the silence of the universe takes on a new meaning. Perhaps many civilizations reached our level. Perhaps they looked up at their skis and wondered if they were alone. Perhaps they debated the same questions we debate today. And then one by one they vanished. Not in a dramatic cosmic explosion, not with a visible signal across the stars, but quietly, locally, permanently. A planet falls silent and the universe barely notices. This would explain why we see no ancient galactic empires. It would explain why space is not filled with relics of long-lived civilizations. Most never survive long enough to leave a lasting mark. In this scenario, intelligence is common, survival is rare. The universe becomes a place where civilizations flicker briefly, like sparks, before going dark. This idea is deeply uncomfortable because it mirrors our own situation. We are powerful enough to destroy ourselves, yet divided enough to struggle with global coordination. Our technologies are advancing faster than our ability to govern them. Our systems are interconnected, making them both efficient and fragile. The Fermi Paradox then becomes a warning rather than a mystery. It suggests that intelligence carries a built-in risk, that awareness and capability may be evolutionary dead ends unless paired with extraordinary restraint. If this is true, then the question is not whether alien civilizations exist. The question is whether any civilization ever learns how not to destroy itself, and whether we will be one of the rare exceptions. The dark forest. There is another explanation for the silence of the universe, one that is far more disturbing than self-destruction. What if advanced civilizations do exist? What if they are everywhere? And what if they are deliberately hiding? This idea is known as the dark forest hypothesis. It begins with a simple assumption: every civilization wants to survive. Survival is the highest priority, everything else is secondary. Now imagine the universe as a dark forest at night. Every civilization is a hunter moving silently between the trees. No one knows who else is out there. No one knows their intentions. No one knows their level of technology. In such a forest, making noise is dangerous. If you reveal your location, you announce your existence to unknown entities. Some of them may be peaceful, others may not, and you cannot tell the difference until it is too late. In a universe governed by physics, there is no way to guarantee safety once your location is known. Faster weapons always exist. More advanced technology is always possible. A civilization that is peaceful today could become hostile tomorrow. From this perspective, the rational strategy is silence. Do not broadcast. Do not announce yourself. Do not attract attention. Any civilization that reveals its presence risks annihilation by a more advanced one, not out of malice but out of caution. The safest move is to eliminate potential threats before they become actual threats. Under the dark forest view, the universe is not empty, it is quiet. Civilizations that survive learn to hide early, those that do not are quickly removed. This creates a powerful selection effect. The only civilizations that persist are the ones that never announce themselves. The sky remains silent not because no one is there, but because everyone knows better than to speak. This reframes humanity's own actions in a disturbing way. For decades, we have been broadcasting radio signals into space, television transmissions, radar pulses, messages designed to announce our existence. From the dark forest perspective, these actions are reckless. They are equivalent to shouting in a forest full of unseen hunters. Some scientists have raised serious concerns about active attempts to contact extraterrestrial intelligence. Once a signal is sent, it cannot be taken back. Light travels outward forever, carrying our location with it. If there are civilizations listening, then we may have already revealed ourselves. The unsettling implication is not that aliens are hostile by nature. It is that caution alone is enough to produce hostility. In a universe where the cost of being wrong is extinction, preemptive action becomes rational. This also explains the absence of visible megastructures. Advanced civilizations would minimize detectable energy waste. They would hide their activity. They would blend into natural cosmic background noise. The universe would appear lifeless, even if it were full of intelligence. The dark forest hypothesis turns the search for extraterrestrial life into something deeply ironic. The more aggressively we search, the more dangerous the universe may become. And the most unsettling question of all is this: If the dark forest is real, then silence is not just a choice. It is a survival strategy. And humanity may already have violated it. We are too early. Not every explanation for the silence of the universe is dark. There is another possibility, one that replaces fear with responsibility. Humanity might be early. The universe is 13.8 billion years old, but that does not mean it has always been equally capable of producing life. In the early universe, the raw materials required for complex chemistry were scarce. Elements heavier than hydrogen and helium had to be forged inside stars and scattered through supernova explosions. It took time for those elements to accumulate, time for planets rich in metals, water, and organic chemistry to become common. In this view, Earth did not arrive late. It arrived at the first moment when intelligent life was truly possible. Some scientists argue that the average habitable planet in the universe may be billions of years younger than Earth. If that is true, then many potential civilizations simply have not had time to emerge yet. Intelligence may be common in the future, but rare in the present. From this perspective, the silence of the universe is not ominous, it is expected. We are not missing signals because no one survives. We are missing them because no one else has started broadcasting yet. This explanation also fits another observation. Complex life on Earth took a long time to evolve. For most of our planet's history, life consisted of simple organisms. Multicellular life emerged relatively late. Technological intelligence arrived only in the last fraction of a percent of Earth's timeline. If this pattern is typical, then advanced civilizations may be separated not by space, but by time. Humanity could be among the first wave. That idea carries an enormous weight. If we are early, then what we do matters not just for ourselves, but for the future of life in the universe. Our choices could influence what intelligence becomes. We might be the first species to face the challenges of global technology, the first to confront planetary scale risks, the first to decide whether intelligence can survive its own power. In this scenario, the universe is not watching us with hostility or indifference. It is waiting. This also reframes the search for extraterrestrial life. Instead of looking for ancient civilizations far older than ours, we may be looking too soon. The sky may be quiet because the story of intelligence has only just begun. The danger of this idea is subtle. If we believe we are early, we may feel safe. We may assume that the great filter lies behind us or that the dark forest does not apply. But being early does not guarantee survival. It means we are untested. The universe may still be in the process of determining whether intelligence is a stable outcome or a brief anomaly. In that sense, humanity could be part of an experiment that has never been run before. We are the data point. The silence of the universe may not be a warning of death. It may be a blank page. And what fills that page depends on what we choose to do next. The most uncomfortable possibility. There is one explanation for the silence of the universe that many scientists hesitate to discuss publicly. Not because it lacks logic, but because of what it implies about us. What if we are not alone, not early, not hidden, and not extinct? What if we are being observed? This idea appears in several forms, but they all share the same core assumption. Advanced civilizations may exist that are so far beyond us technologically that direct interaction is unnecessary, undesirable, or dangerous. In this view, humanity is not a peer, it is a subject. One version of this idea is known as the zoo hypothesis. The universe may contain civilizations capable of interstellar travel, but they choose not to interfere with developing worlds. Just as humans observe animals in protected reserves, advanced beings may observe us without revealing themselves. Interference could disrupt natural development. Contact could destabilize a young civilization. Observation without interaction becomes the ethical choice. Under this explanation, the silence of the universe is intentional. Signals are suppressed, interactions are avoided, emerging civilizations are allowed to develop on their own. Another version of this idea is even more unsettling. What if reality itself is structured to limit what we can observe? Some physicists and philosophers have seriously considered the possibility that we live in a simulated universe. In this scenario, the absence of alien civilizations may not be a mystery at all. It may be a design feature. A simulation does not need to include more complexity than necessary. Rendering countless advanced civilizations may serve no purpose. A single intelligent species could be sufficient to study behavior, ethics, cooperation, and conflict. From inside such a system, the universe would appear vast but empty. The illusion of infinite space would exist, but only one civilization would ever arise. This idea is deeply uncomfortable because it reframes every observation we make. The silence of the universe would not be evidence of absence, it would be evidence of constraint. Even without invoking simulations, there are more grounded possibilities. Advanced civilizations may operate on timescales and energy scales we do not recognize. Their communication methods may not involve radio waves or light. Their technology may leave no obvious signatures. To them, we may be invisible, or worse, irrelevant. There is also the possibility that observation itself is limited by choice. A civilization that has mastered survival may have learned that contact brings more risk than reward. They may choose non-interference not out of kindness but out of self-preservation. In this case, the universe is not silent because no one is there. It is silent because contact is forbidden. This possibility is uncomfortable because it denies us agency. It suggests that we are not participants in a cosmic community but a phenomenon being studied from afar. It also raises a deeply unsettling question. If we are being observed, then at what point does observation end? Do civilizations that reach a certain level of power trigger intervention? Is there a threshold beyond which contact becomes inevitable? Or is silence permanent? This explanation offers no comfort. It does not promise safety. It does not guarantee survival. It simply suggests that the universe may be far more crowded than it appears, and that our loneliness may be an illusion maintained by forces we do not understand. The silence in this view is not emptiness. It is control. What this means for us. After exploring every possibility, the question remains: what does the silence of the universe mean for humanity? The Fermi Paradox is often framed as a problem in astronomy, a puzzle about distant stars and hypothetical civilizations, but at its core, it is a mirror. Every explanation reflects something about us. If we are alone, then intelligence is unimaginably rare. That would make every human life more precious than we can fully comprehend. We would carry the only known spark of awareness in the entire observable universe. If the great filter lies behind us, then we are survivors of a cosmic lottery. We have already passed trials that destroyed nearly everything else. That would make our existence extraordinary. If the great filter lies ahead, then we are standing at the edge of a test that no one has ever passed. The silence becomes a warning written across the sky. If civilizations destroy themselves, then progress without wisdom is a dead end. Our technology becomes both our greatest achievement and our greatest risk. If the dark forest is real, then survival depends on restraint. Silence is not ignorance, it is strategy. If we are early, then our choices will shape the future of intelligence in the universe. We are not just a civilization, we are a prototype. And if we are being observed, then how we behave may matter more than we realize. None of these explanations can be proven with certainty. The universe does not provide easy answers. But they all converge on the same conclusion. The fate of humanity is not predetermined by physics alone. It depends on our decisions. For the first time in Earth's history, a single species has the power to alter the entire trajectory of life on its planet. We can preserve ecosystems or collapse them. We can cooperate on a global scale or fracture into conflict. We can use technology to extend life or to erase it. The silence of the universe does not tell us what will happen. It asks what we will do. Will we become a civilization that learns restraint, coordination, and long-term thinking? Or will we follow the same unseen path that may have ended countless others? This is why the Fermi Paradox endures. It is not just about aliens. It is about whether intelligence is sustainable. It is about whether awareness is a temporary accident or a stable feature of reality. It is about whether the universe can produce beings capable of understanding their own power without being destroyed by it. When we look into the night sky, we are not just searching for others. We are searching for reassurance. Reassurance that survival is possible, that intelligence can last, that silence does not always mean extinction. But the universe does not answer. It simply waits. And in that waiting, the responsibility falls on us. If this video made you think differently about the universe, let me know. These kinds of stories take time to research, write, and produce. Liking this video tells the algorithm that content like this matters. If you want more deep, cinematic explorations of science, mystery, and the questions we rarely stop to ask, subscribe to the channel. And most importantly, leave a comment. Do you think the universe is silent because we are alone, because we are early, or because someone is listening? Your perspective becomes part of the conversation. The universe may be quiet, but the discussion does not have to be.